the middle portion of the country. Sally is currently a 100 mile an hour hurricane as of the latest advisory by the National Hurricane Center. And it's moving off to the west northwest at about 5 miles an hour. It's really not moving all that quickly. And that is as a result of the weak steering currents we've been talking about for the past several days. This slow forward motion is one of the aspects of Sally that is so dangerous for those along portions of the northern Gulf Coast. The slow motion is going to give rain time to pile up to 2 feet and storm surge time to pile into the coastline. So, really not a good situation, the fact that the storm is moving so slowly. Though that does decrease the wind threat a little bit as you head farther away from the coast. Remember, Laura moved so fast that it was able to bring very strong winds well inland across portions of Louisiana. Thankfully, that's not something we have to worry about with Sally here, but the we're going to pay a price for that, and that price is the significantly increased threats due to water. All right, so let's do a little breakdown of the satellite imagery. Really interesting stuff going on here. We saw a little bit of organization earlier in the day. If you remember the stream I did earlier this afternoon, we talked about how the inner core was starting to get going. Well, it sort of faltered and faded and fell apart a little bit this evening. That's probably due to a combination of things, right? There's rarely ever one single thing that you can point to and say, oh, well, that's exactly what happened 100%. The atmosphere is complicated and there are lots of different processes going on here. But let's take a look at a couple of them. So, one of the key things that we've seen happen this evening is a little bit of dry air has been wrapping around the southwestern side of the storm. We talked about that in the afternoon update, and it was sort of isolated off to the south and east of the core, but a little bit of it did wrap around into the core. So that's one of the reasons that we saw the core appearance and structure degrade a little bit this evening. Another is a little bit of southwesterly wind shear. So you remember now that the storm is moving closer to the coastline, it's getting some of the southwesterly winds ahead of this trough. And you can actually see those here, the anvil or cirrus clouds from storms over the southern, central, northern Gulf of Mexico, whatever part of the Gulf of Mexico this is. Those cirrus clouds are moving off from west to east, and that's a signal basically that we're getting a little bit of shear into the system. The cirrus clouds that the storm is producing are fanning out beautifully in this clockwise pattern. This is pretty much textbook for upper level ventilation of an intensifying hurricane. But remember, the atmosphere is three-dimensional. So even though the winds at the anvil level of the hurricane are beautifully anticyclonic, the winds just below the anvil, which you can see, these clouds are at a different layer in the atmosphere, so they're moving in a different direction, and that's from west to east. And that change in wind direction with height is what we call wind shear, and that's causing some problems for Sally this evening. Another thing that's contributing to the sort of different convective appearance of Sally this evening is what we call the tropical cyclone diurnal convective cycle. So that sounds complicated. So I'm going to bring up a graphic that I tweeted out earlier this evening that sort of attempts to explain this. This is actually pretty complicated stuff. So if you don't really follow along, that's fine. This is the stuff that we spend weeks on in atmospheric thermodynamics courses. So but it's pretty interesting, and hopefully you can get the basic idea, even if you don't understand every single bit of it. The basic idea is that convection associated with tropical cyclones follows this diurnal cycle. It's most intense at sunrise and it's least intense at sunset. And why is that? Well, the reason is that there are these what we call circulation anomalies. So it's basically, you think of a hurricane as a circulation, right? Air is moving in at the center, or in the lower levels, and then it's moving up through the middle of the storm, and then it's moving out at the top of the storm, right? So we're getting this in, up, out circulation that's associated with the hurricane. And a circulation anomaly is just saying, are portions of that circulation stronger or weaker than usual? That's what an anomaly is it's comparing whatever thing you're looking at to what's quote unquote normal. So in the case of the hurricane, during the day, we have incoming solar radiation, right? It's coming down from the sun. And outside the hurricane, right, where you see these clear skies, or very thin cirrus clouds. So all around the outside of the hurricane, that solar radiation is coming in, it's hitting the ground or the water, it's heating it up, and that warm air is then rising. So we're getting all this rising motion. This happens all day. So by the time you get to the afternoon, evening, you have all this rising motion away from the center of the storm. And as we know, what goes up must come down. So that rising motion has to be counterbalanced by some sinking motion somewhere else in the atmosphere. And there are two options for that. The sinking motion could happen, farther away from the storm, like way out here, or it could happen over the storm. And the preference is generally that the sinking motion, again, this is not in the literal sense, that there's like actual, the updrafts aren't reversing direction here. This is just an anomaly. So the air is moving up more than it normally would outside the storm, and it's moving down more than it normally would inside the storm. And that's assisted because as our solar radiation comes in over the storm, it hits the clouds, right? This is actually what we're seeing on satellite imagery is the radiation reflected back off these clouds. And they're very bright. They're reflecting a lot of that energy back. So there's cooler air, again, relative to what there otherwise normally would have been. We're talking about anomalies, not an actual physical quantity here. And that means that the air is sort of cooler than it would otherwise be over the storm. Cool air likes to sink, so you end up with a sinking anomaly, which is basically just saying the upward motion associated with the hurricane is weaker than it otherwise would have been. Well, what do we know about that? When you get these cloud tops to be sinking or to sink or at least not rise as robustly as they otherwise would, they warm. That's why you get warmer cloud tops in the evening. The opposite happens at night, when you get enhanced cooling outside the storm, rising inside the storm with the warm air. So, anyways, all that to say, the sun has been working against Sally this afternoon, and that's part of the reason why we see these cloud tops warming on infrared satellite imagery. As the night goes on and we see the diurnal cycles sort of pivot back to being more favorable for convection, we'll see these cloud tops cool off a little bit and see some more intense thunderstorm activity pop up. At least all else being equal, that's what we would expect. So we can take a quick look at some of the Hurricane Hunter data here. This is the latest pass through the Hurricane Hunters. A few things to note here. There really isn't anything earth-shattering. No bursts of rapid intensification to report. The one, probably the most important thing is here are the last four center fixes, right? So the plane came in, it went up over here, it went down through like this, and then back up, and then back down, and then back over. This plane has covered a lot of ground. It's taken a lot of time. Remember the last time I did an update, it was the recon was just entering the storm. So all that time, this is how much Sally has moved forward. That's really not a whole lot. The storm is moving very slowly, and that's again helping to increase the water-related threats, both surge and rain, along the coast. The wind field associated with the storm is relatively broad. You can see here's some hurricane force winds right there. There's some more hurricane force winds at flight level. But they're displaced relatively far from the center, right? In a normal hurricane, you'd see the strongest winds like right in the eyewall here. Well, there isn't really a strong wind max near the center. That's mostly because this is a relatively broad storm at the moment, and so long as it remains broad, it's not really going to be able to ramp up its maximum winds to the extent that a small and consolidated storm might. So that's, I guess, a look at the storm's current structure. I mean, we could go on and on about what implications this may or may not have for what happens on land. But honestly, the storm is still 24 hours out from landfall, if not more. I mean, that's kind of ridiculous. Honestly, if you think about it, We pull up the Hurricane Center graphic here. I mean, it's not forecast to make landfall near the Mississippi Alabama border until 1 in the morning on Wednesday. So we still have an entire, you know, 28 hours, 30 hours of this storm slowly crawling over the warm waters of the Gulf of Mexico, putting off these big convective bursts that are trying to close off the center of circulation, or I mean, the center circulation is already are more than closed off, but it's trying to close off the inner core. So we're going to be watching the satellite imagery basically for the next 30 hours, trying to figure out if this convective burst is the one that can build an eye wall that's durable. You know, I don't necessarily think that there's much of an inference you can draw about what's going to, what the storm's going to look like 30 hours from now based on what the storm looks like right now. Because 30 hours is a long time for a hurricane. It's a long time, especially for a hurricane that's sort of sitting in this marginal environment where, the shear and dry air are putting just enough of a damper on it that it's not taking off and becoming a category 4 hurricane. But it's also the shear and dry air isn't so strong that it's falling apart, right? The shear and dry air are basically being fought to a draw by the storm circulation. And the net result is that, a very small change to the storm's environment is going to result in a very big shift in the intensity, right? So you can imagine that if the shear and the inhibiting factors and the supportive factors for Sally's intensification are basically neck and neck right now. They're two forces pushing in the opposite direction very hard. You can imagine if one of them relaxes for even a little bit, right? Whether that be an inhibiting factor like the shear relaxing and sort of coming down a little bit for a few hours, if it means that a pocket of dry air sort of works into the circulation, and that would be a sort of a temporary boost to the inhibiting factors, if that makes sense. Basically, any small change to the environment is going to produce a very large response in the cyclone's intensity. So, we could be fighting to a draw for the next 12 hours and have a storm that looks almost identical to this by tomorrow morning, except, 20 miles off to the northwest. And then all of a sudden the shear comes down by 5 knots and boom, we have a category 3 hurricane. Or the shear goes up 5 knots and all of a sudden we have a category 1 hurricane. My point is to say that obsessing over each convective burst here, I think is really going to tire you out over the next 30 hours. So um, I would really resist the temptation to say, "Wow, that looks like a giant burst of convection. This is, on its way to being a Category 3 or 4 hurricane." Or, "Man, cloud tops are really warming, so this is rapidly falling apart." Trying to extrapolate much in the way of landfall insights from near-term convective trends is going to be a frustrating exercise tonight and tomorrow. So what can we say about shifts to the forecast as far as impacts go? Well, the biggest thing is the shift in track farther to the east. So this is the last 4 runs of the UK Met model. But if we were to pick any of the other models, the GFS has done this too. The consensus. So this is basically the weighted average of all the different models. And you can see that the forecasts from yesterday, so this was yesterday's afternoon forecast, showing the storm moving inland over southeastern Louisiana. And then the very latest forecast shows the storm moving inland, basically right over Mobile Bay. So that's a pretty big shift off to the east. We talked about some of the reasons for that in the afternoon update, but basically Sally got strong, and the trough that's steering Sally to the north pushed in a little bit. Sally slowed down a little bit, and the net result of all that is that the storm's curving off to the east faster, and so it's expected to make landfall farther east. So that's really good news for New Orleans. That's really bad news for Mobile, Alabama, Pensacola, Florida, and this whole portion of the Gulf Coast that was expected to sort of see the outer fringes of Sally and is now expected to get a direct hit from the inner core, to the extent that the storm has an inner core. It doesn't really have one at the moment. It may not have one when it makes landfall, or it may acquire an inner core, 4 hours before landfall. It's really hard to tell at the moment. But either way, this has been the shift in guidance over the past day or so. This is also reflected in the National Hurricane Center forecast. So this was yesterday morning's forecast calling for the storm to pass west of New Orleans, now calling for a landfall near the Alabama Mississippi border. This means that the impacts from the storm are really shifted off to the east. Really concerned about surge in Mobile Bay. This is an area where the bay is the geography of this area, the shape of the coastline really is effective at funneling water inland. So if you're in surge prone areas here, I really implore you to take this threat seriously. Make sure that you have ways of getting to higher ground if you haven't already. So the storm's expected again to come onshore tomorrow, but the impacts from the system really are already underway. So let's bring up, for the last little bit of this segment here, bring up a look at the current radar imagery. This is what we're seeing, the radar out of Mobile, Alabama. Can see the storm center actually shows up pretty well for all the hemming and hawing we've done on satellite imagery. Shows up pretty well on radar. There's our attempted an eye wall. I say attempt because I don't know if I can really call it an eye wall without seeing a wind max there on recon data. But this station outside of the wind max, or outside of the eye wall, but it's an elevated platform. This is an oil rig, so not representative of conditions that you're going to see at the surface, but it's had a pretty impressive run today. It's been sustained over 100 miles an hour, gusting up to 120 at times, even outside of the area where we'd expect to see the strongest winds. You can also see that there's this rather large wedge, I guess, that sort of goes like this. This is the wedge of precipitation, what I call quote unquote heavy weather, where we have tropical storm force winds, heavy rain, and starting to get some surge flooding too. So this is moving, pinwheeling off to the north and west. It will arrive here along portions of the Alabama coastline within the next few hours, Mississippi tomorrow morning. This is the end of your window to prepare, basically. If you're wrapping up any last preparations you might have to do, by the time this band arrives, it'll be pouring rain, it'll be blowing 40 or 50 miles an hour, and it's really time to hunker down. So clocks out across parts of the Florida Panhandle here. Clocks almost run out across parts of southern Alabama, southern Mississippi, and far southeastern Louisiana. Though really, Louisiana does not look to see the worst of this storm. All right, so that's about all I have for this evening. If you have questions, send me a note on Twitter. I do try to respond to all the questions, but I get a lot of them and I can only type so fast. So forgive me if I don't get to you. Feel free to remind me. And hopefully everyone's staying safe and enjoying watching the live cam footage from Mark and the rest of the team. Thanks so much for watching. I'll be back tomorrow with many more updates about Hurricane Sally.